Delve into the topic of programming your computer with Python. It's only fitting that we're joined by an individual who stands at the forefront of the open source community. I'm thrilled to introduce Glyph Lefkowitz, a beacon in open source maintenance. Many recognize him actually as the brain behind the Twisted project, but Glyph expertise stretches far and wide. From massively multiplayer online games and dynamic web applications, and from enterprise information management software to dozens of infrastructure-related open source projects. His contributions are vast and varied. Without further ado, please extend a warm welcome to incapable Glyph Lefkowitz.
Hi there. Good to see you all. All right. So today I'm going to talk to you about programming your computer in Python. I'll be touching on some tools you can use to do this today, but I'd also like to convince you that this is a worthwhile thing to do. The central thing that I want to convince you of today is that your personal computer, the one in your hands, attached to the keyboard you're touching, is a super powerful machine, both in terms of raw computational power and also in terms of functionality provided by the operating system. And you're probably not taking full advantage of it. You can take control of your computer and get it to do all kinds of cool stuff with Python. You've probably looked at something on your computer and thought, I don't like how that works. But you can't really change it. Sometimes that is true, but Python gives you a lot of power to make your computer behave like you want it to. And in this talk, I'm going to cover 3 different ways to do that. You can probably do this first, at least a little bit, but I'll start with a quick reminder that you can leverage your computer's power by running any code that you might normally run as part of a web app, or in a cloud-based CI system like GitHub Actions, just on your computer. Second, you can use Python to directly control the desktop apps you already use. You don't need to just parse their files, you can manipulate them directly. And third, you can write small GUI apps that do things that you think are important, probably with a lot less work than you might think. You probably already know that Python can do most of that stuff, but it's also probably seemed pretty daunting. There are new, unfamiliar libraries to learn and fewer examples to draw on than there would be for like a database-backed web framework. The main thing I want to show you here is that it's not necessarily that hard, and in particular, it might require less code than you might think. The main way I want to do this is to show you lots of short samples of code. The samples mostly just complete programs that can be run as is. In a few cases, I will have to show just like one function or method that's part of a larger program. But all the examples are real code that I've actually tested. There's no fake, and then some more stuff hand-waving. It all runs. However, the point of getting the code to fit on one slide is not to actually let you read and internalize the whole thing. The point is to allow you to see the relatively small scale of the code and possibly to read the emphasized chunks. Don't try to read all the code on all the slides, just get the gist. To conclude the introduction, I would be remiss if I didn't mention the inspiration I've taken from Al Sweegert's excellent book, Automate the Boring Stuff with Python. The ideas that he describes there are related to the things I'm going to talk about today. However, this is not a rehash of that material. Automate the Boring Stuff talks about a few basic things that are just interesting enough to get novices interested in programming in the first place. And today, I'm going to be assuming that you probably already know Python, right? Show of hands, anybody know Python here? All right, good. Got some Python programmers. And I'm just going to give you some ideas for doing cool stuff that you might not have previously considered. So let's start with the basics. Your computer's pretty fast, but we often treat our computers like dumb terminals. Leave all the heavy lifting up to the cloud CI systems and servers and stuff. But given that Python is used in so many places, why would I make that assumption that we're all leaving our work to the cloud? It's certainly not true for everyone, but a pretty strong majority of Python programmers are back-end programmers. If we look at the JetBrains Python Developer Survey, using Python code to write code for web applications and data science is extremely popular. Python sees a wide diversity of uses, but these are far and away the most popular categories. 43% of Python programmers do data analysis, 43% do web development, and 39% do machine learning. If you're here at PyBay, you're probably doing some of those things. And that code tends to be run on big back-end computers. And while there are desktop applications in Python, it's far less popular for that. In the same survey, under 20% of respondents said that they do desktop development. And front-end web development is so unpopular that it's not even a question on the survey. Not to slag on PyScript, they're taking us to the future, but we're not there yet. I suspect that even this small number is actually a little bit inflated by dilettantes like myself, who do a little bit of desktop development here and there. 19 developers, or percent of developers, means that nearly 1 in 5 developers is a desktop developer. There are 25 talks at this conference, and this is the only one that's even plausibly about desktop development. So, you know, thanks for repping in the survey, but I think we all kind of know we're making it up. Much larger conferences have between 1% and 0% of talks about desktop stuff. So despite the fact that we're writing back-end code, we're typically sitting in front of a desktop or laptop computer 6 to 10 hours a day. Now, we're certainly using our share of back-end stuff. GitHub's a cloud app, and we're using that pretty much 100% of the time. And yeah, when you look at what the data all of us use to write code, the programs that we are spending our days typing into, the data shows that we choose desktop IDEs overwhelmingly. So much so that cloud IDEs like Amazon's Cloud9 are buried somewhere in the 2% other category. So clearly we see the power of our own machines when we want to get our work done, but maybe not enough. So here I have just like a little bit of additional data that might be a quick, easy win for thinking about how you think about your local computer. Just a quick reminder that it's often surprisingly powerful. So for good reasons, there's been a gradual move to move more and more of our test suites and continuous integration into the cloud, and let it do small, partial runs locally just to test out the one thing that we're working on. But when you've got a big build matrix and a lot of parallelism, that could save you a ton of time. I'm sure almost all of you run some of your tests locally, but the knowledge that you can spin up a bunch of jobs at once and have this infinitely large cloud absorbing your CI workloads sometimes leads you to a false sense of relative performance. So, just for one trivial example, in the run-up to this talk, I tried running the full test suite for the Twisted project that I worked on. Not counting the latency from pushing a PR to actually starting the tests, the cloud runner for our test suite took 125 seconds. Locally, it only took 37 seconds. If I need the feedback from my full test suite, not even counting the time that it takes to get the code to the cloud in the first place to run it, I can get that feedback 70% faster by just running it on my own computer. I could buy faster machines on GitHub. I could do a bunch of work to like chunk up the work into parallelizable units and then blast it out in a bunch of different jobs. But I could also just run the tests on my own computer. And why bother when my laptop's already that fast? It's also amazing how capable a server your development machine can be. To demonstrate this, I did a very silly benchmark. I ran Twisted just for a little bit of realism. I did give it like an HTTPS certificate, and I used the HTTP perf benchmarking tool with 50K requests just to get a quick baseline. And I should stress, I ran this on my laptop, no tuning, single core, set it up in about 5 seconds. The test server could process more than 6,000 requests per second, like well more than that. Now, there's no database involved here, it's not a realistic application, but that is a wild number for somebody who's been working on web servers for 20 years. If you have 1,000 people clicking 3 times or 6 times a second each, that's 1,000 concurrent users using barely 5% of the CPU available to this one computer for this one person. It's worth keeping this scale in mind. This isn't even just a demo for your local network. You can host on ngrok. They have a free tier you can point it at your machine. If you have a small app that you need to host for like 10 of your friends, don't bother making a server, it's fine. You can just run it on your computer. Skip all the headaches with Docker and Kubernetes and Terraform or whatever. The eagle-eyed among you, however, may have noticed some asterisks on those previous slides. I feel like it's important to mention the caveats here. There are a lot of good reasons other than performance to put your app on a server. You won't be able to get a single self-hosted computer to be reliable enough to run all of your mission-critical stuff. For security reasons, you probably don't want your laptop accepting random pushes from people on the internet for your CI system. What I'm pointing out here is that as we move to the cloud for reasons like availability and security and repeatability, we don't lose track of the value of also having a usable local development environment. It's kind of unfortunately common for local development environments to decay as teams scale up and depend more and more on like the cloud CI system, just blocking and waiting for slow build queues to run. So this is just a gentle reminder not to do that. But that's also why I didn't want to spend too long on this section of the talk, do a bunch of really intense benchmarks. Mostly, I just want to talk about tools that like help you control that computer. But as we talk about leveraging local computation, it's useful to remember there's like a lot of computation happening. Okay, so now on to something a little more fun. Rather than just getting a little bit of a speed boost, let's talk about enabling new types of functionality. So, to make this a bit more interesting, rather than a few vague hypotheticals, let's tell a story. Imagine for a moment that you're a C-list micro-celebrity in the Python community who's been invited to give a talk at a regional Python conference. You're trying to decide what tools to use to write your talk. You're also like a caricature of middle-aged ADHD, so you're massively overcommitted, and you have a small amount of time to work on the talk. This is a bit of a digression, speaking of ADHD, but it might be useful for those of you who also need to give technical talks. Getting the timing for your talk right is important, even if there aren't 10 minutes of fumbling with HDMI cables at the beginning. So if you have to give a long talk, there are 2 ways to get close to the right length for it. The most common is to write some slides, practice delivering it, see how long it takes, add material or cut material to see if it's too long or too short. The pro move, though, is write it all out as a speech, do a word count to get a quick sense of how long the talk is going to be, depending on your average speaking rate, and then iterate until you're pretty close. That way you don't have to practice it quite as many times. It's been long enough without a code slide. It has been long enough without a slide with code on it. So here, as a little treat, here's a Python function to take a word count and print some time estimates that might be useful in this context. Just a little simple math on the word count and average words per minute speaking speeds. And here's what the output of that function might look like. But here we're going to do a little bit of a problem. For this talk you're preparing, you're familiar with 2 different presentation frameworks. One, Reveal.js, lets you write your talk in plain HTML. It's handy for technical talks because you can include code from external files. It can do asyntax highlighting. You can version control it in Git. And it's super easy to use Python to reach into that HTML document and pull out all of the speaker notes so that you know how long you're going to be speaking. You've even made a few presentations with it before. You're familiar with it enough to be productive, and you've even presented a Reveal.js presentation at the same conference where you're giving this talk. But the talk you need to prepare now is 50 minutes long, and you've got a lot to say. Setting up a whole new Reveal.js project is an annoying amount of work. You don't want to do that on a deadline. This absolutely illegible slide, by the way, is just a head tag. It doesn't even have all the setup that you need to do once you've written that. So a much faster tool for actually writing the talk would be Keynote. It's a GUI, so it's quicker to lay out the slides, easier to work with images, it syncs to iCloud and stuff. Given the tighter timeline, you'd want to use that. So cool, let's use Keynote. But if you're going to use Keynote, how do you get the words out of the presenter notes? How are you going to run that little script that I showed before? With Reveal, it's easy. As I said, you scrape the HTML out using HTML5lib or any one of a dozen projects that are nice, easy ways to parse HTML with Python. But with Keynote, how am I supposed to get it into like its weird proprietary zip file format? Lucky for you, on macOS, the hooks used to script applications via AppleScript are actually exposed to Python. You can access them in a couple different ways, but there's a package called AppScript that makes it super easy. With AppScript, you can easily access the scriptable APIs exposed by Keynote. You can write some code that grabs the first document from the Keynote application, loop over all of the slides, grab the presenter notes, count the words. But then, how do you know which of these methods exists? What is a Keynote app or a document or a slide? There's no types on any of these things. Luckily, every Mac comes with an app called Script Editor, which has an open application menu item that allows you to inspect the scripting dictionary of every application. Here, you can see a browser that shows what a Keynote slide is and where you can learn the name presenter notes. There's a simple system for translating from AppleScript syntax to AppScript's Python conventions. And once you've learned a few quirks, you can easily browse through whatever applications you've got installed to see if they're scriptable and see what features they will present to you. And hey, now that you've broken through the barrier to be able to program Keynote at all, maybe you can address one of the other big advantages of Reveal.js. Syntax highlighting. In fact, it might have annoyed me, I mean you, it annoyed you, in this story that's about you, hypothetically, that Reveal's syntax highlighter doesn't quite work the same way as Pigments, and so it's sometimes hard to get it to recognize new Python constructs like match statements or the walrus operator. Plus, if the highlighter were in Python, you know Python, you could use fun features like everybody's favorite standard library module that you all know, ColorSys. You could add some fun flair to it, like the rainbow identifiers algorithm, which gives every unhighlighted identifier its own unique color, so you can pick them all out easily based on a deterministic hash function of the string. This is all cool stuff that's available just because it's Python. And so all the libraries that you get to bring to bear on every problem are now available for automation. You're not writing in an AppleScript, so you don't have to relearn how to do HSV to RGB color space translation in AppleScript. Definitely not a fun time. And yeah, it's a little more challenging to implement. The whole program doesn't fit on one slide here, but it's still pretty straightforward to create a new slide with a given code layout, populate it with some highlighted code that lives in a separate file, so you can take it and test everything to make sure you're not presenting anything broken, and easily refresh the slides with new code as you write it. So I do think that was a pretty cool example of a thing that you did, but this does immediately prompt the response. That seems kind of like Mac specific. Is this like a sales pitch for Apple laptops? And yeah, kinda, unfortunately. I had thought when I set out to do this talk that the tools on other platforms were kind of more comparable to the way that the Mac does scripting applications, and I'd be able to easily show something similar. Unfortunately, as far as I can tell, Mac OS is like a little bit out ahead of other platforms in this regard. But that mostly just means I can't fully come up to speed on Linux and Windows and the constraints of preparing for a talk. It doesn't mean the tools aren't there. So let's take a somewhat more abbreviated tour through those platforms. Rather than a nice story, I'll just demonstrate like the first thing that I could get to work a little bit, just to give you a taste of what it's like. First, Linux. The easiest option I found to drive Linux desktop apps is via accessibility hooks. This may not be as, this is because not as many apps export a usable scripting interface on Linux. You may notice the slide says import and not pip install. This package, PyATSPI, is already provided by your system Python installation on most Linuxes. And it's a bit of a pain to get the set of tools to compile it for you, so you probably want a system site package as virtual end if you want to avoid that hassle. ATSPI arranges everything into a hierarchy, so we'll start off with a simple generalized tree traversal function. Not a whole lot interesting here, but it can just dig through a hierarchy to find something with a predicate, and I need that to be on its own slide so that this fits on one slide. But once we have that helper, this is the whole script to grab the URL out of a Chromium window. You launch a Chromium browser, you navigate to a website, you run this, it pulls out the URL, and it tells you what page you're looking at. We scan the desktop for an object named Chromium with the role application, then within that application we find an object named address and search bar, pull out its text value. But again, how do I know that I'm looking for address and search bar? Similar to how there's an explorer for scriptable interfaces on Mac OS, there's an explorer for accessibility on Linux called Axerciser that can show you the hierarchy that the PyATSPI module exposes to you. You can dig around for the UI object you want to interact with, see what its name and role are, so you can find it programmatically. It's even written in Python itself. Another way that you can control certain functionality on Linux, which is a little closer to the Mac scriptability interface, is the desktop bus or dbus. There are actually several different options to control dbus from Python. I found DOSBus to be the easiest to use. And here's an example of how to resize a terminal window to the standard 80 by 25 characters in the columns. There are actually two layers here. I'm using the GTK plus actions interface, which contains an activate method and the size2 action, which can be discovered separately via the actions list method. But how did I learn that? Well, there's a utility. There's a browser called dfeat, which does something similar to what script editor does. Or what Axerciser does for accessibility objects that can enumerate all the dbus objects on your desktop. So we have two options for automating Linux, one for Mac OS. What about Windows? Oops. Left that in there. Okay, well, Windows is a little bit rougher. There are tools available to examine some things about its automation technologies, which are alternately called COM or OLE, or sometimes documented in VBA. You can like open regedit to get keys under HTML software classes, and then there's like a tool that comes with Python Win that's, this screenshot's telling me something about some objects that I have installed, but I'm not quite sure what. Unfortunately, most of the examples of automation I could find that were really interesting were for Microsoft Office applications, which I wasn't quite willing to purchase just to do an example for this one talk. But I was at least able to piece together that you can pass these OLE programmatic identifiers into win32com.client.gencache.ensure-dispatch and get an object with the methods described in the Visual Basic for Applications documentation. Again, I didn't have that much time to look at this, so in some sense, while this is not the most impressive demo, it's also something that you can do very quickly if you're just getting started. This opens up the Windows shell, also known as File Explorer, grabs its first open window, prints out the URL to the folder it's viewing, and then resizes the window a little bit, because that was a property that I could change. Note, however, that despite the fact that I don't have great specific guidance for getting started with comprehensive reference documentation on Windows, PyWin32 does have this one extra nice feature that, unlike the other automation tools we were looking at previously, Python's built-in object introspection, like dir, just works on these objects, which means that if you use something like the Python Win IDE bundled with PyWin32, idle, or a Jupyter Notebook, something that does runtime introspection to give you tab completion, you can kind of once you can get that initial array object, you can kind of bumble around the API, just type in dots and hitting tab until you get to a property that looks like what you want. And it kind of works okay. So I've shown you ways to control other applications, but what if you want to write your own? This is a little less awkward and a little better supported in terms of what the bindings can do. Before we get into how, though, maybe we should ask why. You get a lot done with command line tools and web pages. So what's the point of even bothering with desktop UIs? The first thing about desktop UIs is they make it easier to exert finer control over exactly what your computer will do when you push a particular button. So just for a really trivial example, I hope that this is a relatable experience and I'm not just like a bumbling old man here, but when I head to a web page where I want to type into a text field, sometimes some JavaScript misfires, or like I hit tab or maybe space or page up or something, and then suddenly my keyboard focus is like over here. And I don't know why it's over there. The web page can't handle any of the keyboard events, and so my muscle memory doesn't work, so I start trying to tab back into the page, and then I'm like all over the address bar, and it's going down the links on the page. And this is kind of one of the benefits of a browser-based UI is that there are browser UIs which let you do things like search the page, rotate between links, but that also means is you're giving up a certain amount of fine-grained control when you build a UI this way. A particularly intense form of this sort of control might be global hotkeys, actions you want to take while you're focused on any application, starting and stopping a time tracking timer, opening up quick reference documentation, locking your screen, maybe even something like restarting a development server if you're using a development process that involves multiple apps. Your command line or web-based application can't enable input if they're not already focused by the keyboard. Related to those sorts of global actions, there's also persistence. It's all too easy to write a helper tool for yourself. You want to run kind of in the background most of the time to manage something, but then you forgot to start it, keep it running all the time, you open a terminal window, you accidentally hit Control-C when you're focused on the wrong things. UIs that are kind of front and center tend to be easy to shut down. But if you just fork it off into the background, you have no way to interact with it. Desktop OSs have had facilities for years for interacting with these kind of background things. On Mac OS, it's up in the menu bar, and Windows is down in the system tray, and it's handy to be able to put stuff there. Another little bit of desktop UI that's helpful for those persistent background things are notifications. Every major desktop OS has a little place to pop up for non-interrupting reminders of stuff that's happening. It might be useful for your Python code to be able to use those. Another thing that desktop apps can do that you can't really do from a web page or CLI is a heads-up display that presents information continuously. I won't really have time to get into this during my talk, since the code is a little more involved once you have to start actually drawing stuff on the screen. But my open source timer app, Pomodoros, has some examples of drawing translucent UI that covers the whole screen on macOS, and I've worked in prototypes of similar displays for Windows and Linux. Finally, your desktop OS actually has a bunch of capabilities that don't really fall neatly into any of these categories, and are just things that it can do that either leverage some hardware that it's running, or does something with just services that are part of the OS that you can't really replicate yourself. Mac OS has core location, Windows has its geolocation service, Linux has GPSD and GeoClue, and they can all be made available to Python by wrapping the kind of native APIs for the OS. Geolocation is just kind of one example that isn't hyper-specific, but the way that I'm going to demonstrate it jives with the way that you would do a bunch of other different things. So, hopefully that collection of benefits, more precise UI control, system tray elements, notifications, varied display options like heads-up displays, platform functionality like geolocation, or even just controlling tab order a little more tightly has made you maybe a little interested in trying this out. But how do you do it? The first step is to not get too ambitious. It's easy to dive into the deep end, overwhelm yourself with complexity. If what you're just going for is a couple of native-looking UI elements in a different app that you can like Alt-Tab over to that isn't part of your web browser, the standard library's got you covered. tkinter, for example, has got a little bit of a bad rap. For many years, it was pretty ugly, inconsistently supported, and honestly kind of broken in a lot of platforms, so the community sort of drifted away from it and doesn't talk about it a lot. I still probably wouldn't use it for like a big budget, high stakes desktop experience commercially, but the core Python team, not to mention the unsung TickleTK team, has been quietly improving it in the background for years, and for a lot of basic use cases, it's pretty great. It's also cross-platform, and any of the big three platforms I'm talking about in this talk pretty much works right out of the box. So this tiny little program, created from the standard library's documentation, is really all that you need to get started. This was definitely the quickest demo that I had to cook up for this entire talk. Although you might look at this window and think, it's not super ugly or anything, but the padding's kind of off, it doesn't look very polished. And sure, it takes a little bit of work if you want it to look good. But if you haven't taken a look at idle, Python's built-in tkinter-based IDE for a while, you might be surprised at how pleasant and polished it looks these days. You can really get a lot of mileage out of this super simple, cross-platform, beginner-friendly, and thoroughly well-documented tool. For that even finer grained control that I spoke about earlier, I released a library for the Mac called Quick Mac Hotkey, which is a single platform thing, but it's really easy to use. Once again, fully functional demo looks like this. This globally captures the Command-Control-J shortcut until the user presses it and then unregisters it. The whole library is basically just this one decorator, and with any application using an apt-get main loop, you just run it with PyObjective-C or run it as part of any other tool. It just works. There are also some more portable options if you want something that runs cross-platform. It takes a bit more than a slide's worth of code to get the PyPI package global-hotkeys going, but it'll let you grab hotkeys on every platform, and it's not that complex. I also write a similarly tiny library called Quick Mac App, which I'm using in a few applications. It makes a little status item for the menu bar, runs a twisted main loop for you too, so it's helpful for back-end processes. You could do whatever networking you need. And here's the one slide example. You just decorate your function with the main point decorator. Set up your status menu by instantiating a status and calling menu on it with some items and their callbacks. And squeezed in among your status items, now you'll see your new Python. Next, if you want to pop up a notification, it's so simple that you don't even need to write any Python code. You can if you want to. It's a library, and it's extremely quick to create and populate a notification with it. But if you want to try it out, the included Notify Py command line tool will pop up a notification on macOS, on Windows, and on Linux, all using the native notification centers for each platform. Okay, next, let's determine our geographic location with these fancy platform APIs. For Windows, we can install the WinSDK package, which is a community-supported fork of Microsoft's lightly maintained WinRT API bindings for Python. And on macOS, we can install PyObjective-C framework core location package, which wraps the built-in core location framework. We could also pin install PyObjective-C, but that installs like 100 frameworks, and you probably don't want it. This here is some code to request the location from macOS. Once again, there's a translation layer here. PyObjective-C has a little bit of documentation to get you started on the basics of writing a Objective-C binding, but core location is documented by Apple on their developer site. It's not a Python thing. The main thing here is that we implement this location manager underscore did update locations underscore method, which is documented in Apple's core location documentation, like this. Now, you don't need to learn Objective-C to be able to write to access these APIs, but you do need to do like a little regex substitution in your head where you see a method signature like this, and then you translate it in your head to a Python method signature like this. Similarly, we can use the Windows API that does the same thing. Similarly, we look at Microsoft's developer site, and similarly, we do a translation in our heads not from Objective-C, which I kind of know a little bit, from C#, which I definitely don't know at all, but can still perform this very simple substitution. And once we can see it as a Python signature, it's easy enough to call. Whew, okay, that was a lot. I was going to be talking fast even before the extra few minutes of display configuration. So let's summarize. Broadly, there are two ways you can make your desktop or laptop computer use some cool tricks. One, you can use a cross-platform library. I gave a tour of tkinter and Notify Pi earlier in this talk, but there are plenty of others. Toga, PyQt5, WXPython, Kiwis, or GUI libraries. There's even more cross-platform stuff you can go reach out to other frameworks for. These libraries can wrap a ton of functionality, and they typically have full documentation in Python. You rarely need to learn much in the way of any new skill. It's just Python. You just read the API docs like you would read any other docs on user docs for the Python framework. If you need the full unredacted power of your entire platform, though, even that isn't too hard. There's a bunch of different options for translators. On macOS, you've got AppScript and PyObjective-C. You've got WinRT and the Win32 API on Windows, and you've got GTK, Gobject, Dbus, and the accessibility APIs on Linux. Your operating system's native APIs do have a bit more powerful, but you always need to learn to translate from the system's native language into the Python idiom for accessing that language in order to leverage the automatic wrappers that have been written. However, the documentation for those platforms is extremely extensive, and if you want to learn how to do something you've seen another app do, the information is definitely possible to find. Probably without even leaving one of these main documentation sites, there's also communities for each of these things. So, having gotten through all of that, I wanted to give this talk for a couple of reasons. First, I've got some ulterior motives. I use all of these tools. I do try to automate my computer pretty regularly. I'm working on a few desktop apps, and by far the most painful part of this process is dealing with documentation that's out of date or incomplete. As you've seen, actually using these libraries is fine. The code fits on a slide in pretty much every case. There's not a lot of tedious boilerplate, but figuring out how to get started, or if what I want is even possible, can have some pretty high static friction as I try to get into these communities and figure out whether the libraries work at all. For one thing, in order to bubble up the good current documentation to the top, search engines need to have new content where people are linking to the good resources and letting the older content kind of fall off the edge of history. Fresh blog posts that actually document the state of the art. Even if a library is actively maintained and still works great, if every blog post about it is from 2009 and is in Python 2.6 syntax, it's not very helpful. Maintainers also need the sense that people are actually using their stuff. When new people show up and ask questions, it makes the effort of maintaining the project feel more meaningful. And honestly, a lot of users of these desktop APIs just don't tell the framework authors that they're using them at all. For one quick example, and I don't want to throw shade at the maintainers here at all, I just want to point out that one reason I chose DASBus rather than the kind of original Python dbus is that its documentation includes a couple of revealing issues that indicate this lack of community engagement. To be clear, it's not that DASBus has replaced it. Python dbus is software that people do use. It's got 5,000 downloads a day on pypi.org. But it still documents certain things on its read the docs page like this. The unique instance idiom is important enough for a whole section in the documentation, but the section reads, "Fix me, provide exemplary code, put in examples." It leaves me wondering, do I really need to know what the unique instance idiom is? So that's it for me and my purely selfish motivation. But there's a second reason that I wanted to give this talk, and that's what I hope I can give to you, the audience. The software industry's reputation has been a little tarnished, deservedly so, over the last few years, and in the noise about the struggles of the titans of tech, we can sort of lose track of the small, personal, joyful experiences that computers can produce. We can artificially limit our thinking about possibilities based on economic pressures and day-to-day concerns. We put barriers in our own minds. So let me tell you a small story about the very start of my software career, about the first time I experienced one of those barriers. I did not start programming in Python. I started programming in HyperCard in the early 90s. I didn't particularly... yeah, Team HyperCard. All right. I didn't particularly want to be a programmer. I wanted to be a writer, in the hand, writing right there in the logo. But as an 11-year-old, I was a big fan of Choose Your Own Adventure books, and the possibilities of interactivity intrigued me. One of the most famous success stories for HyperCard was the 1993 breakout hit video game Myst. Oh, we got a whoop for HyperCard, not for Myst. It's a weird audience here. All right, I used the simple tools I was already using, card transitions, background images, custom cursors, to produce this feeling of being immersed in an imaginary world. Of course, one big difference between my work and theirs was the use of color. Attempting to do this in monochrome doesn't quite have the same vibe. The problem is, while HyperCard was a super friendly authoring interface that was appealing to a kid who did not want to be a programmer, unsuccessfully apparently, HyperCard did not natively support color, and it required a binary extension called an XCMD in a different programming language. This was real programming. Exactly the sort of thing I found intimidating and didn't really want to get into, Even installing the X command for color, which was already done since this was using it, if I knew where to get it, which I didn't, required skills that I just didn't have. Attempting to do that required leaving this, the comfortable, easy world of HyperCard offering, to the world of ResEdit and compilers and the Macintosh Programmers Workshop, and a bunch of other tools that were immediately baffling to me in their complexity. So I gave up. As a teenager at the dawn of the internet, with no credit card, this was an insurmountable hurdle. I couldn't get those tools, and if I had gotten them, I wouldn't have known what to do with them. But if you wanted your computer to do something magical today, you already have the skills, you already have the tools, and it's only a pip install away. Just go for it. And I'm going to try to finish a little bit early, because we will run a little bit less behind. So yeah, thank you everyone for coming to my talk. Really appreciate your attention. I'm Glyph. You can find me on the internet. I also want to thank my few patrons on Patreon, Jason Walker, Moshe, Matt Campbell, and Sergio Bost, who all are supporting me in writing extremely idiosyncratic talks like this one, which definitely would not have been a sponsored talk. So, thank you very much once again, and enjoy PyBay.